Today's speaker is Helen Thom. For those of you who have been to previous meetings, you probably recognise Helen. Helen's back for either a fifth, sixth, maybe seventh session now, so thank you very much, Helen. Helen is a customer service manager at NHS BT who has many years experience as a specialist biomedical scientist in red cell immunohematology. So for a long time, Helen was the person that we'd send all our difficult red cell serology cases to. So very knowledgeable, very experienced, and very passionate about this topic. And the lectures are equally cheesy, and I believe we're expecting a Halloween themed session today. So we'll see how that goes. I'm going to not waste any more time. I'm going to hand straight over to Helen to get us started. So thanks again, Helen, for joining us today, and over to you.
You're very welcome. Thank you for inviting us to speak again. I do enjoy doing these, and I hope everyone else enjoys them. I've got some antibody IDs for you, so we're just going to go through those, but I've just tried to incorporate a bit of Halloween fun, just making it a bit light-hearted for everybody. So there will be polls throughout, so they should just appear on the screen. Feel free to join in. They're all anonymised, I'm not going to share if there's any wrong answers or anything like that, but please join in and I hope you enjoy it. Thank you. So today's talk is antibody ID, and is it just a bunch of hocus pocus? So the outline of today's session, we're going to cast a spell as a group, but some of the letters are missing, so we need to find out what they are. So you're going to have to use your serological wizardry to find the missing letters, and we need to decipher the puzzle, fill in the missing pieces, and then cast a spell. I hope you're as excited as I am about this. So what you'll need, though, to be able to cast the spell is your wand, which is your pipette. You need a vial of Thackeray Binks's blood, and if anyone hasn't seen Hocus Pocus, you're going to wonder what on earth I'm talking about, but he's one of the characters from that. But it also needs to be labelled in accordance with BSH guidelines, so name, date of birth, unique identifier, etc., etc. And we'll also need runes. They are the antigrams that we're going to use, and these will reveal the letters. But there's a few rules that you've got to follow when you're going to cast your spell and work out what it is. So, and you've got to follow your BSH guidelines, as we've said. So when we're identifying antibody, it's really important that we make sure that there isn't anything ugly lying underneath. There's no more alloantibodies, and this is just to prevent a patient from having a transfusion reaction. What you've got to do when you're doing your exclusions, which I'll take you through as we'll go through the panels, you've got to make sure that you, in particular, have excluded anti-JK and JKB, big S, little s, Duffy A, Duffy B, and they've got to be excluded using homozygous expression. For those of you who aren't familiar with that term, that just means that they've got to be, say if it was Duffy A pos cells, Duffy B neg cells, not heterozygous where they might have a weaker expression. And you only need a single example for each phenotype for exclusions, but as you'll see when we go through, I personally like to use two, but I think that's just coming from a reference lab, and you see lots of weird and wonderful. One of the other things that will come in quite handy when you're trying to decipher your runes is that some antigens can disappear when you add a special potion, which is called papain. And here is papain. This is what we'll use when we're enzyme treating with cells. So if you sprinkle papain, include that in your spell, then some of those antigens are going to disappear. Whatever's left over, so say your RH and KEL, they can be enhanced. So if you're using papain treated cells, that's your enzyme panels, you will lose some of the antigens. That's just something to bear. So we're going to do our first poll just as a sort of a practice. So hocus pocus.
If they don't have binary.
So Danny, are you all right to launch the first question, please? That poll will appear there. So have you seen Hocus Pocus? So if you just put yes, no, or maybe because you can't remember. If you can't remember, you mustn't have seen it because it's brilliant. Fingers crossed, those will come up. New maybes there. You need to watch it, it's very good. Just give that another few seconds there because I don't want to take up too much of your time today. There's lots of no's. I'm a bit disappointed by that. I think one of your CPD things, we should hold on sending out the certificates until you've confirmed that you've watched Hocus Pocus. Right. Oh, there we go. Half of you haven't seen it. Some of you aren't sure, but well done to those who have. So we'll go on to the next slide. So is it time to cast a spell? So this is the spell that we need to complete and decipher the puzzle. But you can see there's some letters missing. So we're going to go through the next few slides and find out what those letters are. So firstly, what I want you to do is you're going to have to take your wand and you're going to perform a long group. So we're getting ready for our next poll question here. I'll just get your finger at the ready, Danny. So what is a long group? Because some of you might be sitting there thinking, what on earth is Helen talking about? So what is a long group? Is it a forward group only? So that's when it's just the patient's red cells. Is it a forward and reverse group? So that's the patient's red cells and the patient's plasma. Is it a reverse group only where you're testing just the patient's plasma? Or is it a group that takes a very long time? Just want to submit. Starting to come in thick and fast there. Give it another few seconds there. I appreciate that some of you might not be able to take part at this if you're on a computer and you're sharing with others. There we go. We'll take that as done now. So we've got that is a forward and reverse group. I will explain those now. So one of the things you need to bear in mind when we're talking about something that's a forward and reverse group is you're probably familiar or you'll have heard of Landsteiner's law. So this was Landsteiner's law. So individuals produce antibodies to the antigen that they lack on the red cells. So essentially, if you're missing an antigen from your red cells, you're going to make that antibody in your plasma. These are naturally occurring, and this is why it's so dangerous, and it's really important to get your ABO correct, because if you have an ABO incompatible transfusion, it can actually kill you, and that's an NHS never event. So Landsteiner's law states that for whichever ABO antigen is not present on the red cells, the corresponding antibody is found in the plasma, and this forms the basis of your long group. I noticed that someone did say that it takes a long time, and it does take longer to do a long group rather than a short group, which again I'll explain. This is a long group. I've just, for representation here, I'm not affiliated with Biomedical or anything, but this is the technology that I used when I worked in the lab, so that's why I've used these cards. So your long group, you look here, you add your red cells into these. These are known anti-sera. So in this well, the first well there, you've got anti-A, then you've got anti-B, you've got anti-D, and then you've got a control just to make sure that your tests work properly. And you're mixing these with unknown red cells. If the corresponding antigen is there on the red cell, it will mix with the anti-sera. You'll get a positive reaction. When you centrifuge that card, you get agglutination, and it shows here at the top. You can see from this card that there's no reaction with the unknown cells in your anti-A, which means there's no A antigen there, but there's a B antigen there because you've got a positive reaction with that, and there's no D antigen, and your controls worked. So then what we're doing, because it's a long group, you've also put your unknown patient's plasma. You don't know what antibodies are there. You've mixed them with known red cells. So in this well here, we've got A cells, and in this well here, we've got B cells. Following Landsteiner's law, you should have the opposite antibody. So whichever antigen you're lacking, so they're lacking the A antigen from the red cells, they should have anti-A in the plasma, which they have. So this just sort of, it's a confirmation that your forward and your reverse group do match each other. So this would pass all good, and we'd call it D. It is D as well, but for this, we're just more interested in the B. And don't forget your 2-sample rule. So you can do a confirmatory test. So this is your short group or forward group only. So you're just testing what's on the patient's red cells, and you can use this for your confirmatory sample when you're testing in the lab. So using these, and I've already given you the answer, but what is Thackeray's ABO and your first letter? So if you can launch the next question, please, Dan. I feel we should almost have the countdown music. So if you just put in there what you think based on those results, even though I accidentally gave you the answer, you think the blood. While we're waiting for the results, I see there was a hand there, but they've put the hand down. If you wanted to ask something, that's fine. Yep. Hi there.
Sorry, I think I'm unmuted now. I can't seem to see the polls. They're not coming up. The questions or the polls aren't coming up on my screen. Is there somewhere I should be looking for them?
Sorry, they should just be appearing on your Teams screen, or they might appear in the chat. If you are having issues, if you quickly leave and rejoin, it might come up for the next one. But if not, I'll just read them out. So for this one, it's just what is that with ABO, and then I've just got A, B, AB, or O.
Okay. Thank you.
Sorry about that. Thanks.
Just a note for everybody else, depending on what version of Teams you're using and whether you're using the desktop version or the browser version or what device you're using, that can also affect whether or not you see the polls or not. So we are getting lots of responses to the polls, so they are working for some, or for most of them at least. Apologies if they're not working for you. Please just use the chat box if you'd like to answer. Sorry, Helen, over to you.
No, that's fine. And I will read the next questions out. So right, so far we've got 97% of people have responded with group B, which is correct. There was a response there for AB. It isn't AB because there isn't the A antigen present, so you're just looking for what antigen is present in your forward group, and then what corresponding opposite antibody, is there in your reverse. But a lot of this is done on automation as well. But you would, and if you were doing manuals, you would always do a second check and get someone to check that for you. Oh, on to the next one. Yay, we found reverse letter. These are just a few little facts about B. So I've just taken these directly from the blood donation website if anyone wants to go on and have a look. So around 10% of the UK donor population are group B. Within that, only 2% are actually group B negative. So quite rare-ish, if you were to say that. So, and I'm group B. I'm B positive, just so if anyone's remotely interested. And then here, it's just a few little things of who this blood can go to. Not dwell on that too much though. So we've got the first letter, so we can fill in the B's on here now, but it's still not enough to be able to perform the spell. We'll best continue on. Now we're going to move on to the antibody ID. For anyone who has managed to complete them, great. I hope it's been nice for you to sort of have a practice with the panel. But for anyone who hasn't had the opportunity, don't worry about it. They're there. You can always have a try later on if you want to. So what I do when I do an antibody ID is I start at the right and I just sort of move down until I've hit the first positive, because I'm wanting to see if the positive reactions from here match up with the positive reactions on here. So I'm essentially matching a pattern. Then I move along and it's a negative there, so I can actually exclude that antibody, because here it's saying that there's a positive reaction with the cell, so the cell is antigen positive, but my antibody ID result is negative, so I've excluded that antigen is, the antibody's found its antigen, so I can get rid of it. That's gone. According to BSH guidelines, you would actually be able to exclude this antibody now. It's not a heterozygous, it's not JKB cell, so I can exclude it using this because it's a homozygous JKB cell, but I just like to go on and do a little bit more. So just move on to the next one, move along. That's positive there, so I can't exclude it, so I've got to move on to my next positive. Down we go, move it along. Great, that's negative. Strike through, then it's done. And you can, at the top, I would just go, right, I've got 2. I'm really happy with this. If you really wanted, you could go all the way down and cross them all out. It's however you choose to do that. But as long as you're following your BSH guidelines and excluding, you can do single specificity on a homozygous line. Then we've got similar again with the JKB, that's gone. And then just to avoid me getting repetitive strain injury from clicking the mouse several times, I've just sort of like pre-done all of these exclusions. So for anyone who hasn't had a chance yet, just take it that these are okay, because otherwise we'd spend 1 hour doing one antibody ID. Then we're going to move on. We've got to the point we've done this where we've got to M. I'm going to move down, then I'm going to move along. Can't exclude this because it's a positive reaction there. So I move down to my next positive. Same again, positive reaction. Looking like it could be this. Move down the next positive. Same again. Looking good. go down, I cannot exclude the presence of anti-M. At this point, though, how I do this, someone might say, oh, well, what I'm going to do is I'm going to confirm the presence now, whereas I'd like to just finish my exclusions. I like to finish my exclusions and then I'll go back to confirming if that's the case. So again, just to avoid repetitive strain, I've showed that we do have the exclusions there. You can see with the RH antibodies as well, what you're able to do with those, you can exclude an RH antibody using an enzyme panel. Just if I'm not aware of that, that is accepted within the BSH guidelines. Then what we're going to do, we're just going to take a quick look here at the M that we've possibly, anti-M that we've possibly identified. And just look at a few clues that would just confirm. Obviously, you would have to phenotype your patient, provided they hadn't been transfused recently. It'd be okay to do that using your anti-serum. So the first one, we've got this nice positive reaction, quite strong, 3+. Go down, we've got another one there that's 3+. And then this one here, I just want to draw your attention to, because anti-M can actually show dosage. So here you'll notice that this is classed as a heterozygous cell because it's M positive and it's N positive, and N is its antithetical antigen, which is like its little friend. And you've got a weaker reaction there. So they are things that you can sort of pick up. And sometimes with a weak expression of anti-M, it might even miss the heterozygous line. So that's almost just a sort of double check with just watching the strength of your cells. And it's also sensitive to papain. So because we've sprinkled papain on, because it's a magic potion, because it's Halloween, there's no reactions there. So it's just another way of sort of confirming. So hopefully everyone's happy that that is an anti-M. Like I said, we do a phenotyping. Give cross-match compatible blood via IUT. All is good. Yay. We'll found the second letter.
And I said, you were doing well with the sign language, but then she said, I'd like them to sing.
Funny. So we've just got a few little facts here about the M antigen. So they have said it's destroyed by papain. Apart from, so this is the M&S system. They're all destroyed by papain apart from anti-U. That's just something to bear in mind, and it does show dosage. Clinically significant if it's reactive at 37 by IAT. So if you had just a cold panel, it's not counted as clinically significant, and you wouldn't need to provide cross-match compatible by IAT. You could if you wanted to, and if you've had an anti-M in the past but it's not currently detectable, you don't need to supply antigen negative blood. Anti-N, unlikely to be significant, cross-match compatible, and then just information there about the rest of them, which I'm happy to share the slides if anyone wants more info. But I'm just cautious of time and that we've got a few more antibody IDs to do. And we've got another poll for you to do. So very quickly, so is the M antigen sensitive to papain? And for those of you who can't see the poll, it's just a yes or no. You can pop your answer in the chat if you want, or just satisfied that you get the right answer at the end of it. So is it sensitive to papain? This is just a test to make sure people have been listening. Right, oh, got lots of responses coming through there. Fab. But we've got 96% of people are saying that yes, it is sensitive to papain. So essentially that just means that it's destroyed by papain. So there's varying terminology that can use. So if it's resistant, it doesn't get destroyed. If it's destroyed or denatured, you can, well done everyone. And for those of you who did the antibody IDs, hopefully you got that as well. So is it time to cast the spell yet? Nope. So we've filled a few more blanks in, and for those of you who've seen it, you might already know what the spell is. I won't ask anyone to come in and sing it, don't worry. So we're going to move on to the next one. So we've got another antibody ID here for you. And this one, I'm not going to go through all the exclusions because it does take quite a bit of time. But I'll just give you the moment just to sort of have a quick look at the positive reactions and just see if you can match any up for those of you who've not had a chance to do that. We've got this line here. We've got 2+ reactive by IAT, and it's 3+ reactive by enzyme IAT. And again here we've sort of got a stronger reaction, 3+ and 4+, and then 2+ and 3+. So these are things that you're thinking if you didn't do your exclusions, just looking at this as a general, this is something that's not destroyed by papain. It's not sensitive, so it's one of those ones that's resistant to papain. So you're looking here at your sort of your RHs and your KELs, and you do exclude. So for this one, it is anti-big K. And just a few points to note about this one. When you look in the BSH guideline, it doesn't really mention about dosage for the K, well, for big K. But you know, I've seen thousands of these in my lifetime, and I do find that it does tend to show dosage. Sometimes it's not down as being, it might not be markedly enhanced by using enzyme cards when you use the neutral cards. But if you use enzyme IAT, which is using the cards that have anti-IgG impregnated in them, sorry, you do get an enhanced reaction. So you can see there you've got your weaker reactions with your heterozygous lines and a stronger reaction with your homozygous lines. Quite straightforward, that one. This is probably something that you see in your laboratory. Nothing sort of particularly weird and wonderful, but not everything is weird and wonderful, even in the reference lab. We have a lot of these. So yeah, you found your third letter. So as I've said there, it's the KEL blood group system is resistant to papain. It can show dosage, and all KEL system antibodies can cause HDFN, but it's a different way to sort of HDFN-C by anti-D. So this affects the precursor cells. So it doesn't matter what the sort of titer is, it can impact the pregnancy. So a woman who's made anti-big K would be monitored every 4 weeks up till 28 weeks, and then every 2 weeks after that, regardless of the strength of the titer. Anti-big K is clinically significant, and if they've made that antibody, they need antigen negative blood. Anti-little k, this is a high incidence antibody. So 98%, I think it is, of Caucasians are positive for the little k antigen. So if you do see it, it's classed as a high incidence antibody, because not that many people in the 0.2% overall will be negative for that. It's clinically significant, and you need antigen negative blood. Anti-KP is one of those ones where it may be clinically significant, so it doesn't say whether it is or it not. You know, and if you look in the antigen facts book, it'll say may cause transfusion reactions, may cause HDFN. So you've just got to be mindful. But for that, you don't need antigen negative blood. You just need cross-match compatible by IAT. And anti-KPB is clinically significant. This is another high incidence antibody. And if you are unfortunate enough to encounter one of those, you need antigen negative blood. So, is it time to cast the spell yet? So, no, we have managed to fill a few more in though, but we're getting there. The cauldron's not bubbling away yet. And I've got just a little random fact for you there. So, we're going to launch another poll. So, true or false, Chilano, which is your little k, is an anagram of the patient's surname of whom the antibody was first discovered in. Is that true or false? Little Helen's random fact of the day. Most people going with true. It's starting to creep down a little bit there. It might just be something I retain weird information, so this is just something that I was probably told once and I've never forgotten it. Answers in there, I'll just give it another few seconds. We'll just leave it there. It's almost sort of 70-30, so it is actually true. And the surname was Nicella, but what they did was renamed it Chilano because then it fit in with the KEL system of things beginning with K, even though it begins with little c. So just something. Hopefully you'll all retain that piece of information now. You might get asked it in a pub quiz. I doubt it, but you know. So we'll just move on to the next one. So we've got another antibody ID there because we weren't able to cast the spell. So this one, again, I haven't gone through sort of, I'm going to move down here, I'm going to do this and this, but what you might have noticed about this panel, if I'll just give you a few moments in case you haven't had a look, but just see if there's anything that you can sort of spot about this that makes it slightly different from the other antibody IDs that we've looked at today. hopefully you've realised that the only negative on this panel is line 3. And I don't know whether you've noticed anything in particular about this panel. You may not. Give you a spoiler alert just yet. So what we're going to do, if you do want to do your because you will need to do your exclusions on this panel, I would move down to my first positive. I can't do that because that's positive. So I move down and I've got positive here and I've got negative there. So you might be thinking, oh, this is good. I can exclude anti-JKB. This is one of those where it's actually heterozygous expression of both of these antigens. You can't actually exclude this antibody because you need to be able to exclude it on a homozygous expression. So just bear that in mind when you do your exclusions. Move along to FYB. You can actually get rid of that because it's homozygous expression. We can't exclude Duffy A because this is the only negative line and it's negative. Can't exclude, this one out there. You can't exclude LAB, but you can LAA. Can't get rid of KPA, you can't exclude that. Can't exclude big K, these ones here. You can get rid of big S because that's on a homozygous cell. Get rid of these ones, all single expressions. So you can see from this panel, even though you do have one negative, there's quite a few things that you can't exclude there. You could argue that you can give, you could give RH matched if you wanted to, or antigen matched, but in a lot of cases you don't want to waste precious phenotyped units. You do need to exclude the presence of these antibodies because we've identified something, so we need to make sure that there's nothing underneath so that we don't give a patient a transfusion reaction. So at this point, what you might do in the lab is think, well, I've got another panel that might be positive for different antigens, and you could put that up, or more than likely you would send it off to your local reference laboratory. Now, this isn't one of your panels, so don't panic if you're sort of looking at, if you've got your sheets in front of you and you haven't used it. This is what you would see from the reference side of things. So we would also do that first confirmation just to see, right, what is this? I think it's a little E, would use this panel. Oh, I've just gave an answer there, sorry. So what you might notice about this panel is that all of the reactions are negative. But if you look right down at the bottom, we do have a K control, which is positive. So this is just a weak anti-sera control. This is an incubation control, just to show that the test has actually worked. My back, sorry, I froze there. So in case you missed that bit, this is a K control that we use just to show that the tests actually worked. Remember to put your plasma in. So these are all negative. And what you might notice about this cell is that the entire panel is made up of, they're all little e negative cells. So it's all it's called an R2 panel. Using this cell, you can actually exclude the presence of all these antibodies on there, apart from little e. What you might notice about here is on your little e, this panel is actually little e negative. So the entire thing is little e negative. So you're thinking, hang on, on my first panel, it looks like I've got little e. But on this one, I can't actually say that it is because there's no cell to sort of go, yes, this is a little e. And this is just the way that the panel is made up. So what you've got to do to confirm the presence of this antibody is go back to your original panel. And you'll see here that the pattern matches up as though it's a little e. As though it's a little e, which is great. If you look at your IAT and enzymes, it sort of confirms it. The pattern matches up. It's also enhanced by enzymes, which Rh antibodies are. And what you do when you're confirming the presence of an antibody, you've got to have 2 positive examples and 2 negative examples. So on this panel alone, we only have 1 negative example. So you use your other panel to give you all those negatives, but you've got to go back to this original panel to confirm that you've got 2 positive examples. Plus you've excluded everything else, so you know there's no combinations of antibodies there. So hopefully that will make sense. Does anyone have any questions, or feel free to pop anything in the chat, or want to put your hands up? Oh, and just another thing as well, with the little e panel, it's only by IAT. So if I go back, you might notice that there's no enzyme panel there. And R2, it's not very common. So we don't waste it with enzyme treated and things like that, because you can use this to exclude the presence. But if you did think there was something else going on, you could just try and use different little E negative cells to find something. Hopefully that made sense to everyone. So we found our fourth letter. So when we're talking about RH, they're all enhanced by papain. And when you find an RH antibody, it's in the BMSEDG guidelines that you would match for extended RH, just because, you know, they are quite immunogenic. What you don't want to do is the patient to have, if they've already made one antibody, they're a responder, and what you don't want them to do is make further antibodies, so you're trying to prevent further alloimmunization by giving RH matched. Say for sickle patients, they're RH and K matched as well, and it's just to prevent them from making additional antibodies. Excuse me. So, and just a few facts just about your sort of common RH antibodies. So we've got anti-D. We know this is clinically significant, and it's the most immunogenic after ABO. Just a little fact there for you. And it's most significant in terms of HDFN, which obviously why there's all the prophylaxis and sending things in for quant. An antigen negative blood is required if you have these antibodies, even if they are previously detected with something like your anti-M, as long as it's not reactive at 37 degrees. So your big C and your little c, these are both clinically significant and they're implicated with HDFN, particularly anti-little c, which will be sort of probably the next one that you would see after D. And again, antigen negative blood's required. Then you've got your anti-big E and your little e. So your little e is the one we've just found. They're both clinically significant, implicated in HDFN, and again, antigen negative blood required. There are some other ones within the RH system, and it just depends on what antibody you find. Always just check to see what the clinical significance of that is, because it's similar to KPA. You've got these ones where they might be clinically significant or maybe clinically significant, like your anti-CW, but something like a CW that is just cross-match compatible by IAT. See, this makes sense. So we've got another poll coming for you. You can't contain the excitement. So in the UK donor population, only around 3% of people are little e negative. Is that true or false? My answer in. I don't put my answers in, it doesn't show them. I like how it's just sort of moving. Just gonna say I'll get a 50 and then we'll stop while I jump over 50. So we've got almost 60 responses. So 88% of people are saying that that is true, that only 3% of the UK donor population are little e negative. And that is true. So that's your R2. So, you know, when you're putting orders in for R2, it could just be that the stock is not available in your centre and we're having to move it around, and that's because there is just a limited supply of that blood. So that is something that you should only order if you really need it. You've also got your R double dash, which is a sort of, that's the D negative version of R2, which is incredibly rare, and we actually keep units of those in the frozen blood bank. Yeah, most people's phenotype is little e positive. Move on to the next one. So, is it time to cast a spell? Well, the cauldron isn't bubbling. If you're going through, we're nearly there, but there are just still a couple of little things missing. You might have guessed what it is, but I'm not going to tell you until you've done your antibody ID. So this is our antibody ID, and we are approaching our final letter now. So this is sort of similar to the previous one that we've just done, where I'm not going to go through all the individual exclusions, but I will just give you a moment to see if there's anything you can sort of think about, how it looks like, which ones are negative, which ones are positive. Oh, not a couple of minutes, but a few seconds there, just for those of you who haven't done it. Like I said, if you haven't had the opportunity to do it, Danny had sent them round, so feel free to do them later. And you can always write on, you know, well, I think it could be this or be that. This is what I would do. So here, how I've approached this is I've got 3 negatives. The first 3 lines are negative, the negative by enzyme and the negative by IAT. So when I look at my other reactions, this is before I've done any of my exclusions. I'm just looking at this and I'm thinking, well, whatever it is, it's reactive by IAT and it's enhanced by enzymes. So automatically you're thinking of those ones that are resistant to papain. Then if you go through and do your exclusions, you want to see what you can get rid of. Great, we can get rid of JKB on that second line, but we can't actually get rid of it on the third line because that is heterozygote. You can't use that one. But you've got your one exclusion following your BMSEDG guidelines. So if you did want to exclude that, feel free to go ahead and do so. So that's that one gone. And then we've got the same with the next ones. And again, this is just me avoiding repetitive strain and you not wanting to watch me click my mouse 20 times, I'm sure. So then we'll move along. I haven't been able to exclude anti-KPA. Now we're looking at big K. You can exclude big K. That doesn't fall into one of those BMSEDG guideline ones where you say that it's got to be excluded on a homozygous line. It doesn't mention that about big K. So you can exclude it on a heterozygous line, but I have seen quite a number of homozygous only big Ks in my time. So it's just, I'm not saying that you can't do it because it's in the guidelines and you'll be following your guidelines, but just being mindful when you are looking for your antibodies, particularly ones that are masked by something like this. Then we're going to next. So we can't get rid of LUE or P1. Not worried really because they're not clinically significant. We just do cross-match by IAT. And everything else is gone. So with this panel, unlike the little e, you can actually get rid of quite a few things, but doesn't mean that you can actually get your 2 positives and 2 negatives for the antibody that you would be looking at. So what you need to do at this point is you might have another panel that you want to use, or you'd probably again refer it to your reference laboratory. And then we'll have another one of these panels. And again, this isn't one that I've sent out, just so you're not looking, thinking what you're doing here. So again, we're just going to have a look at this, a quick close look at this panel and see what we can spot around it. So first off, unlike the little e panel, they're nearly all negative, but one of them is actually positive. And what you might notice about all of these cells is the previous one was all made up of sort of combinations of R2, or R2, Rzs. This one is mostly an R1 panel, and this is called the R1 panel. And we'll take our naming very seriously. What you might notice though is line 5. Sorry, yeah, we've got the pattern. You might have noticed, spotted, if you've done your antibody ID, you'll have found it as a little c. What you notice on line 5, that's little c positive there, and it's positive there, so it's saying, oh, looks like a little c. And you can get all your exclusions, which is great. So the only thing you can't exclude on this panel is little c. But hopefully what you're thinking is, hang on, I've already done my antibody ID on the other one, so you've got to go back to your original panel. Well, I've already excluded the presence of anti-little c, so it can't be anti-little c. But if I look at my R101 panel, it really looks like a little c. What's going on? And you look again and you're like, hang on, it really looks like a little c. And you're thinking at this point, could it be a heterozygous? Because sometimes RH do show dosage as well. But if you look at line 3, that's what you've excluded on. Homozygous little c, negative for big C, and it's negative here. So that's a homozygous. So if it was a weak expression of anti-little c, you would expect this to be positive. This one here is a heterozygous, so that's big C pos, little c pos. And it is positive, but it's the same strength as the rest of them. But the fact that it's hit the hetero but missed the homozygous one just shows that it's not a little c. So you're definitely right. You're just sort of like in the back of your mind confirming that it is. You have excluded the presence of little c. It's not just because you've missed a weak expression of it. Take another close look. It looks a bit like a little e, to be honest, if you're looking at it. All these cells are little e positive. But again, you've already excluded the presence of this when you've done your initial antibody ID. What is it? So then you look at all of these antigens. You know from the previous one that you've excluded the presence of any other antibodies apart from what looks like a little c. So this is where you've kind of got to think, well, it's obviously something that isn't listed here, because when you're making panels, you can't account for every combination because there's so many antibodies out there. Your sheets would just be pages and pages and pages, and would take hours to do that. But again, one of the things I do is just, it's looking at your phenotype. So for this one, it's looking like it's something that's RHE because it's enhanced by enzymes, very similar to a little c and a little e. And all of these cells have got something in common, and that's a little r. So the little r phenotype is little c, little e in combination. And these two here, these are, even though they're not little r, they do have a little r with them, so they're heterozygous. So all of these have got a little r in common. So they've got a little c and they've got a little e in common. What do you think it could be? So what antibody do you think this is? So we're going to do for next poll, and I just want you to have a think about it and put the answer in what you think it is, and then we'll just have a little chat about it. Are you all right to launch that, Danny? Sorry, mine hasn't come up yet. I don't know if it's... Yep, lovely, thank you. So what antibody do you think it is? Do you think it's anti-little c? Do you think it's anti-little e? Do you think it's anti-F, which is anti-little c, little e, sort of in combination? Or you've lost me, haven't got a clue. Feel free to put those in. There are loads of responses. Got a few you've lost me, which I completely get, because I remember finding my first one of these particular antibodies and just wondering what on earth was going on. Right, that's great. We've got 83 responses, so we've got a couple of percent saying that it's anti-little c. Not anti-little c because you've got to use your two panels in combination, and we've actually excluded the presence of that. But it's perfectly understandable that you'd be thinking that it's a little c. But because you've excluded it on the homozygous and on your other using sort of just the way the antibodies would show and work, you've definitely excluded that. Interestingly, nobody thought it was little e, which is good. And you've lost me. So for those of you who lost you, I've lost. Hopefully the next couple of slides will help to explain this. And for those 86% of you who've got that it's an anti-F, which is also known as anti-CE, that is right. And well done. As is, you know, it's a difficult one to identify because it's not here. It doesn't tell you what it is. And it's something that you've just got to learn, because when you're looking at it, you don't know that, but it's just learning the blood group systems and how different things work and how you would see them. So I wouldn't expect someone to walk into a transfusion lab on their first day and go, oh, that's an anti-F, without knowing anything about the history. So hopefully these next few slides will help you. And this is our final letter, so I hope you're not too disappointed, but we're almost ready to cast the spell. So we've found what anti-F, it's part of the RH blood group system. It's clinically significant and it can be implicated in HDFN. And if you have an anti-little f, you've got to give antigen negative blood. It can be described as a compound antibody. And the reason for this is because it's little c and little e together. Think of it almost as they've been combined, they're glued to each other, and it's one entity. It's not anti-little c plus anti-little e, it's a combined thing. And it is also known as anti-little c, little e, or little c, little e compound. Just say it in a Geordie accent very quickly, and then you have it. Yep, James? I see your hand. Okay there. Sorry, I don't know if you're stuck on mute or not.
Hello.
Oh, hi there.
Yeah, the RH group, I do know they show some form of a mosaic. They can form a mosaic on the red blood cell. So can we say the little c, little e is forming a sort of a mosaic
Yeah, that's probably a really good way of putting it, actually. I mean, the terminology I've used is sort of a compound antibody.
Okay.
But yeah, you could say it's a mosaic, and it's to do with the way that the sort of genes. So I've got in this last box here, I'm going to talk about the genes and how they sort of work, if that's all right, if you're all right, hang on a moment.
Yep, thank you.
Thank you. And I've got another hand up there. Sorry, I can't see who it is.
Hi, Helen.
Hiya.
Am I audible?
Hello.
Am I audible? Hello.
Hello.
Is it similar to anti-G with D plus C specificity?
It's not, and the reason is anti-G is something that anti-G travels alongside your D antigen and or your big C antigen. So in order to have anti-G, you've got to have either a D antigen or a big C antigen, whereas the little c, little e, it's kind of something, it's the way that the genes formed. And sorry, they got James who's just spoken there, you know, it's a good description, it's a mosaic. So the instructions for that protein, think of them as just they get glued together, so it becomes one entity. So it's not a little C antigen and it's not a little E antigen, it's just CE as one. But I will explain that on the next slide. But good thinking with the anti-G though. But the anti-G is sort of, you've just got to have, it's like the friend of D and the friend of big C, if that makes any, that's probably the easiest way to put it. And I can put something in the chat later because I've done a previous talk around anti-G, so I can point you towards that if you want.
Oh, okay, thank you.
Thanks. So we're F phenotype, so individuals who are F positive, this occurs when it's the little c and the little e are on the same gene. If we look at this last column here, so when you've got your Rh genes, you've got Rhd, that comes on a gene on its own. But with the Rh, with a big C, big E, little e, there's one Rhce gene and it encodes for all of those antigens. So what you would inherit, say, from your parents is you can get one Rhce gene, which would be positive for your big C, little e. You'd get another gene which is positive for your little c, big E. There's a gene which is positive for little c, little e, which would give you your little c and your little e antigens separately. But in this case, because they get mushed up like that mosaic, I love that, I'm going to pinch that, you end up with them together. So instead of having a separate little c and a separate little e, you get an F, but you could also have the little c, the little e, and the F. And then there's a very rare where you get the big C, little e in combination. So you can inherit these from your parents. So I'm going to show you on the next slide is when you inherit these genes, what your phenotype is. So this, for example, this is probably, I've tried to explain F in my own little way. So because these genes, the C and the E, whether it's big C, little c, whatever combination you have, they travel together on the same gene. So I'm R1, R2. That's my phenotype. So if you did an extended Rh group on me, you would see that I'm positive for the big C antigen, the little e antigen, the little c antigen, and the big E antigen. So I've inherited big C, little e from one of my parents, and I've inherited little c, big E from the other. Obviously, there's all the different combinations you can get, but this is specifically if you're R1, R2, you've got this Rh, big C, little e gene, which is your R1, and you've got your Rhce gene, little c, big E, which is my R2 portion. So I'm F negative because on here, even though I've got the little c antigen and I've got the little e antigen, so I wouldn't make anti little c and I wouldn't make an anti little e because I'm antigen positive, I don't have F because I don't have those two mushed together. But someone who is F positive, they will inherit from their parents. They'll get the Rhce gene, so that'll give them a little c and a little e, but they can also get the F gene, but you can't look at it and know that it's an F because it's just that the little c, the little e, they've become stuck together, so they're a compound antibody. I hope that makes sense to people. So with the anti-F, with the F antigen, you're F positive. You're not going to make that, even so you have these antigens, you just have different combinations, whereas an R1, R2 has all of those antigens, but they don't have F because they don't have them stuck together because they've got an R1, R1 and an R2, R2. They don't have the little c, little e together. I hope that makes sense. And if it doesn't, you'll be thinking, what the F? So I promised Danny I wouldn't swear. And these are just a few examples of some F negative phenotypes and some F positive phenotypes. And all I've done there is I've just put the highlighted in red that the little c, little e is together. So if you're F positive, you've got to have them. You could have the little c antigen, the little e antigen, but you could also have F, which is just like another one. So you can get, like, there's 3 combinations of things that you can get from there. So if you do make an anti-F, the likelihood, because of the ratios of the phenotypes and things, chances are you're going to be D positive. You're going to be R1, R1, R2, R2, or an R1, R2. So if you want to give blood to somebody who had anti-F, so take me for example, I'm R1, R2, you wouldn't know by looking at the phenotype on the bag that that is an R1, R2, so you'd have to give me R1, R1 blood, which is F negative. You could give us R2, R2 blood, but why would you possibly want to waste your precious R2, R2 blood on someone who isn't R2, R2? So go for the R1, R1. Hopefully that will make sense. But if anyone's got any questions, because I appreciate we are starting to run out of time now, you can drop me or Danny an email and I'll be happy to have a further discussion about that. So, is it time to cast a spell? Well, if we have a look, the cauldron's bubbling away and you can see this now. Hopefully this sound's going to work, because I didn't really want to be singing to you on the call. I don't think anyone wants to hear that. Fingers crossed. And I hope you like that. And we've just got one more very, very quick poll for you. So antibody ID, is it just a bunch of hocus pocus? I've pre-warned Danny about that one. So yes, no, or you haven't got a clue. I'm hoping that it's not, I haven't got a clue. Oh, interesting that people have put no, because I did think it was just a bunch of hocus pocus. But in my head, it's like, because it's magic and it's wonderful, and I'm a massive nerd, and I just think it's so great. So hopefully you've all enjoyed that. And well done, everyone who has done that. You're all fabulous. Thank you very much for taking part. And we've just got a couple of minutes left for questions, if anybody would like to go through that. So I hope you've enjoyed that. Thank you.
Thank you so much. I did warn everybody, but it would be cheesy, funny. I didn't really know what to expect, to be honest, but there we go. We do have a couple of minutes for questions, if anybody does have them. I'm going to just start scrolling up in the chat just to see if we did miss any. But please do fire them into the chat box or raise your hand. We've probably got time for 2 questions most, so jump in.
I do try and keep things short so that there's time for chat, but then, you know, it's an opportunity to do all the antibody IDs, isn't it? So
absolutely, lots of comments coming in, Helen, some immediate feedback, some thanks. And
oh, thank you.
Yeah, and we've got
just came up there.
Yeah. Is that? I'm sorry. Oh, it's gone down. There we go. Okay, well, just whilst we're waiting to see if there are any questions, I will just go over some closing remarks. Once again, just a big thank you to Helen. And I think we can maybe achieve a virtual round of applause with the applause tool if we can.
Thank you.
There we go.
I just hope everyone enjoys them. I do enjoy doing them, and I like sort of passing on that to people, and I hope it's interesting for you, because it's stuff that you might not come across in your daily life.
It absolutely was. Really enjoyed it, Helen. Thank you. We can issue certificate of attendance for this meeting, and to obtain that, please just complete the short evaluation that we've sent out in the joining instructions. I will try and get it posted into this chat as well. Do that right now for you. Once you've completed that, it'll ask you for your email address. Please make sure that your email address is correct. We get a lot where people have accidentally put a comma instead of a full stop, and the process is automated, so you won't get the certificate. We've got time for the one last question, I think, and we'll go to James with his hand up.
It's just a quick one. How do we get the slides or the video? I suppose it's going to be quite helpful. Thank you.
Absolutely. So we record these meetings, and in about a week's time, once we've done the editing, it will go onto our YouTube channel with the other 20 or so videos that we've recorded. So give it a week or so, and then go to the Patient Blood Management England YouTube channel. I've linked that in your joining instructions, so you'll be able to subscribe and get the updates when they're published. And I can see that Kuru has put their hand up again. Do you want to come in for the final question? Apologies on if that's the incorrect pronunciation. Okay, and we'll skip to Simon then. Simon Hughes. No, one.
Can you hear me?
Yes, perfect.
All right. I was a bit confused when you said it would be so co-expressed and becomes a compound. Why is it referred to the F, right? Why is it referred to as an antibody instead of an antigen?
Sorry, because what I was referring to when I was on about it being a compound, it's classed as it's more the antigen that's classed as a compound. Therefore, you make the antibody against the compound antigen.
Okay, perfect.
Thanks.
So the anti-F is an anti-compound antibody.
Yeah, so it's the anti-compound against the little c, little e compound that's forced together. What one good place I will sort of point you in if you're after anyway, and it's somewhere that I use for sort of, especially when I was a trainee, is Blood Bank Guy. It's fabulous at explaining this kind of thing. He does a great podcast on RH, and he also has a glossary as well. So I do use that myself. So I would definitely recommend having a look there if you're interested in more reading.
Yeah, thank you very much.
Yeah. Someone else has just put there, how can I have the strong foundation to be able to read this kind of antibody ID accurately? I would say it's just practice. Hopefully you're in a lab where you've got access to sort of training, and it's just picking other people's brains. If you're wanting to see anything weird and wonderful, sort of contact your local reference centre and see if they're up for having visits and things like that, and they'll be able to show you stuff. You've also got your blood centre tours that you might be able to do, or contact Danny and myself. I'm happy to send out example antibody IDs to people if they want. I've got previous stuff that I've done if you just want some practice. And just antigen fact books, going online, like I said, Blood Bank Guy and things like that. So in the patient YouTube channel, there's lots of other things on there that heavily features quite a lot of sort of talks around antibody ID, which will be good for you.
Absolutely. Just a massive thank you again to Helen, and a massive thank you to all of you who joined today. At one point we had almost 200, I think 197 on the call, which I think is a record for one of these meetings. So a really good afternoon, really enjoyed that one. Best wishes, we'll see you soon. Thank you very much.
Thanks everyone, bye.